my comments get caught at the beginning here. I just wanted to talk a little bit about the Unit 2 exam, which almost all of you have completed. So thank you for doing that. What I'm doing is I'm almost finished going through your work that you've uploaded and regrading the exam to see if I can give you partial credit. So please keep an eye out sometime either later today or tomorrow for a change in your exam grade. Okay, so it will probably go up from where you remember it. And also what I do is I will download the actual exam that you took with the correct answers and with my comments on any of the questions where I gave you partial credit. And I'm going to upload that to the Unit 2 exam assignment. So if you go in there, you'll be able to look at the exam, see my comments, and maybe get a better idea of where you might have had a problem. In general, from looking at them so far, the exam grades are very good. So yay. Okay, but again, if you're having trouble or you're struggling, that's a good sign to reach out. So again, I'm not done with all that yet, but I should be by the end of the day today. Okay, so does anybody have any general questions on the exam? Anybody at all? Any general exam 2 questions? No? Okay, so again, the strategy for all the exams is pretty much the same. The week before you take the exam, we'll kind of go through my version of a practice exam. You also have an opportunity to play with a practice exam yourself before you take the real one. And then, of course, there's the real one. So hopefully that's enough practice. I realize in the environment we're in, short of you setting up a one-on-one appointment with me, there isn't the same dynamic of like going over review questions. But we'll try to make it work as best as we can, okay, given what we're working with. Okay, so if there are no general questions, what I'd like to do today is to move into statistics a little bit further. We kind of just introduced it last week as a general topic in math, and we described the difference between inferential statistics, which this class doesn't cover, but you probably will see in GBS 221 if you're taking it, or Math 206, where you actually make predictions based on sample data you have. What we're going to be talking about in this class is purely descriptive statistics. And today's topic is kind of one of the main ideas about descriptive statistics, namely, if you've collected a bunch of data, where's the middle of it? Usually real data isn't what's called uniform. In other words, it's not spread out from the highest value to the lowest value evenly, okay? It generally is lumpy, okay? And there's usually a bigger lump than most where the data middle is, okay? And that's what we're going to be talking about today is measures of center. Okay, so basically what you want to also realize is all of the examples we're using in the course are pretty contrived. By that, I mean, you're looking at a very few number of data points. Even if we're talking about 30, that's not really a lot. Okay, so the idea of needing statistics to tell you where the middle is might not be obvious to you. Okay, you might say, well, what do I need? I just look at the data. I can see where the middle of it is. If you have hundreds or thousands or hundreds of thousands of data points, you're not going to do that. Okay, you're going to need statistics to tell you where the data's middle is, as well as just how spread out it is. Okay, so let's start by letting me share my browser with you, and I'll show you where we are in the course. Okay, so we are currently in week 11, okay, and we're going to be talking about measures of center. I'm going to be using measures of center notes, which are right here, okay, and when we meet again on Wednesday, we'll talk about variability. I just want to scroll down to the online tools, okay, for this week. Okay, I have an online descriptive statistics calculator for those of you who don't have a TI-84. I'll try to show you how to use both. okay, the online one, as well as the one that comes in the TI-84. All right, so again, not being sure who has what, I want to give you some options. And again, this is embedded in week 11, but remember towards the end of the course, there's this module called Online Tools and Calculators that has everything all together. It seemed like a few of you struggled to find that when you were taking your exam. Okay, remember all of the stuff that you need is in Canvas. If you prefer to use your TI, that's fine. I'll show you how. But if you don't have a TI, it doesn't mean you're lost and you're stuck doing everything by hand. Okay, so I'll be referring to this online descriptives calculator. And of course, remember, we all have a login to Office 365, which means you can use Excel, even if you don't have a desktop version of Excel. Okay, so please, wherever possible, whenever you're doing statistics, use technology. Nobody's going to ask you to calculate this stuff by hand outside of a course. Okay, so please get comfortable with the technological tools that are out there. It's far more important to understand what the statistics are telling you, as well as when to use what to answer a certain question, okay, rather than to do all the calculating by hand. So again, I'm going to be using measure of center notes. So just give me a moment while I get that open. And meanwhile, I'll also open the chat in case anybody has general questions. Of course, always feel free to unmute yourself and just ask. And let me share that with you. All right, everybody should be able to see section 3.2, Introduction to Data Analysis, okay? All righty, so hopefully, again, that's visible to everyone. So what we've done so far, based on what we talked about last week, is we've managed to collect data, and we didn't spend a lot of time talking about building a random or a representative sample. You'll have an opportunity to discuss that a little bit in this week's discussion post. But again, you'd collect the data, and it's important to collect a valid sample. All right, and then once you do that, you would organize it in such a way that it's easier to look at rather than just having a set of data points. Okay, we talked about that a little last time with building frequency distributions or histograms. Now what we're going to talk about is, all right, you've got the data, you've displayed it in a nice way that makes it easy to look at. What is it going to tell you? Okay, so that's the analysis step. One of the things you want to learn from your data is measuring its center or typical values of the data. Like we said a little earlier, data is lumpy, okay? And usually if you collect a sample, more often than not, there'll be a value around which most of the data will cluster, okay? So the first measure of center is called the mean, all right? It's also called the average, okay? You're very, very familiar with taking averages, okay? You essentially add up all of the data values and divide by how many they are, okay? But let's talk a little bit about some terminology and some symbols, okay? So what I'm going to share with you is, again, a little terminology and notation. In statistics, there's the difference between statistics that deal with a population, okay, and statistics that deal with a sample, okay? We talked a little bit last time about the difference, okay? A population is all of the elements or people or whatever it is you're looking at that you would be interested in, and a sample is a subset of that, hopefully a random representative subset, okay? So when we're talking about sample statistics, we're going to be talking about the sample mean, and that has the symbol X with a bar on top. It's read as X bar. okay? And it means sample mean, okay? When you're talking about N, usually that is the sample size, okay? Which is the number of data points that you're dealing with. Okay, so let's say you are collecting a sample of South Mountain students and you want to survey 200 people, 200 would be your N. Okay. When you're talking about your data value, okay, so essentially, usually your data values are called X's, right? X's are your data values. You usually count them by using a subscript next to the variable, right? So you have X sub 1, which is your first data value. Right? And then you have X sub 2, which is your second data value. And X sub N is your nth, right? Or the last one in your sample data value. Okay, so you'd have X sub 1, X sub 2, X sub 3. It's important to realize these numbers are not performing any kind of a math operation. Okay, they're not exponents in anything, they're just labels. Okay, so I'll put that down here. Subscripts are labels. So they're just labeling your points. Kind of like what we did earlier in the course when we were doing optimization. If you remember, sometimes we had variables that were X, Y, and Z, and other times we just called our variables X sub 1, X sub 2, X sub 3. This is exactly the same idea. Okay? And we'll also use the Greek letter, this Greek letter here that looks kind of like a backwards 3, is actually a capital letter sigma. Okay, and sigma is the Greek letter S, and it represents a sum. So if you have this type of notation, the sum of all the X sub i's, it means the sum of all your data values. Okay, so the sum basically means go through the X sub i's, starting with the first one and going to the nth one. Sometimes they'll explicitly represent that by putting something like this underneath the sigma. I equals 1, meaning your start value, and an N on the top of the sigma, meaning that's where you stop. And here's what you get when you actually add everything up. X sub 1 plus X sub 2 plus X sub 3 all the way to X sub N. Okay, so basically that's what the sigma is doing for you. And why do we use that notation? It's kind of a shortcut, so we don't have to write out all of these, add-ins in the sum. Okay, this is a more compact way of saying just add up all the data values, add up all your x's. Okay, everybody good so far with the terminology? Everybody all right with that? Anybody questions? Okay. Not seeing questions, so I'm assuming we're okay. All right, so again, sample mean is the mean that's calculated using the data values from a sample, right? Remember we said that was a subset of the entire population. But sometimes we'll be interested in a population mean. Okay, when you start talking about inferential statistics, one of the things you're going to want to do is try to estimate your population mean based on information you have from samples. Okay, so we have to have a way of referring to sample mean versus population mean. Okay, population mean could be everybody. All right, now here's a quick way to tell them apart. when you're talking about population statistics, you're going to be using Greek letters. Okay, so population statistics, think Greek letters. Sample statistics, you're going to be using regular, English letters. Okay, like X and S. Okay, so the Greek letter for population mean looks like this. Okay, and it is a lowercase mu. Mu is the Greek letter M, okay, which stands for mean. Okay. All right, so whenever you see this Greek letter, okay, you're thinking, oh, that's a population statistic. Okay, when we talk about variability, you'll notice there's the same distinction. When we're talking about a sample measure of variability, we'll be using English letters. And when we talk about population measures of variability, we'll be using Greek letters. So here is how we would figure out the sample mean, okay, X bar. It's just adding up all of the data points and then dividing by how many we have, okay? Another way to write it is here's the sum of all the data points. And notice I'm leaving some out in the middle because I don't know how many there are. I'm just ending with n, whatever n is, and then we're divided by n. Okay? So again, this is one of the things that a lot of folks are really comfortable doing by hand. Okay, but I want to show you some tools that are built into the TI as well as the online descriptive statistics calculator linked into the course. So let's take a look at an example. Okay, so the data below represent the costs of different detergent brands. Okay, so this is obviously a sample, right? Because we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It couldn't possibly be all the detergents on the planet, right? Because we're probably not taking into account ones that aren't manufactured in the US. Okay, so it is a sample of 12. Okay, and so they're asking us to compute the sample mean. Okay, before you start adding all the stuff up, okay, I want to show you one way to do this in a TI-84. Okay, and then I'll show you how to use the online descriptive statistics calculator, which is really simple. Okay, it's a good idea to not do it by hand because chances are you're going to eventually want more information from this sample than just the mean. So in your TI, we have lists that allow you to manipulate data. So let me share my TI with you. Okay, so everybody should see my TI. I'm going to turn it on. Okay, and I'm going to put these data in a list. Okay, so if I go to Stat and then Edit, you'll see I have list 1 is empty. Let me just quit for a minute. If you go to Stat, one thing I want to show you here on the Stat menu is Clear List. Okay, I would strongly recommend you clear lists before you type data into them. Once you've decided you don't need what's in there, you can say Clear List, and then you can type in whatever lists have data. Remember, the list names are above your digits. So if you want list 1, you're going to say second 1. Then if you want another one, put a comma, second 2, and so forth. And then you hit enter. The calculator says done, and it's gotten rid of all the data that was in those lists. The reason you want to do that is it's very easy to make a mistake entering data, okay, whether it's in a spreadsheet or whether it's in a calculator. But especially in the TI, if you've got junk in the bottom of your list, okay, you may wind up with data from a previous problem in your list and it's going to mess up the statistics. So get in the habit of clearing out your lists before you start. So now I'm going to go to Stat, Edit, and I'm going to put these data in the first list. So I'm just typing the numbers and hitting enter after each one. Uh, 435, 228. another 228, 220, 229, 222, 368, 229. Okay, and then just make sure your list is pointing at list 1, element 13, so you know you didn't miss anything. By far and away, the most common mistake people make with statistics is typos. Okay, so don't worry about those. Quit out of here. So second mode to quit out. And then if you go to stat, okay, you're not going to want any of these things because most of these are inferential statistics. Most of what you're going to use is up here on list. Okay, so second stat, you can see you've got ops, okay, which will sort your lists and fill your lists and all sorts. Let's go to math, okay? So you can use mean if you want. This is one way to do it. So you click on mean, and then you put your list name in here, and it'll give you the mean, okay? $2.54. Okay, that's one way to do it. Another way to do it is to use something on the stat key. So stat, calc. Do you see the first one in calc is one variable stats? Okay, this is one variable descriptive statistics, everything you want to know about the sample pretty much. So I'm going to click on that. Okay, I don't have a frequency list, but one variable stats gives you the opportunity to put frequencies in, say, list 2. So if you're reading things out of a frequency distribution, you put the values in list 1 and then the frequencies in list 2, and then you could put a frequency list here. Okay, so calculate. And then you have to search for things, okay? See X bar. X bar is the first thing that comes out, and that's the mean, and we got the same thing, okay? This one variable statistics gives you a whole bunch of other useful things. In particular, we'll be talking about these variability measurements down here, okay? And then maybe once you get into GBS 221, you'll be interested in these measures of position called quartiles. Okay, we'll come back to median later. Okay, but the only difference with one variable statistics is you need to look through the data to find what you want. Okay, so you've got two ways to do it on a TI. If you wanted to use the descriptive statistics calculator that's in our course, the one that I've linked into our course. Okay, I have that up here. Okay, and basically it says enter data set, and you have to choose whether it's sample population. Okay, this is important. Make sure you click sample. And it will give you the size. It'll give you X bar, see X bar right here. Okay, so you would look here. It will also tell you the mode and a whole bunch of other stuff. Okay, personally, the online calculators are really handy. Okay, they're especially handy if you're doing a lot of calculating and you just want to copy and paste your data set. Okay, let's see how I might do that. Okay, so I'm going to go back to my notes. Okay, I have data right here, but because of the way I'm mirroring this, I'm not going to be able to copy and paste. But if you're doing it from, say, more from your homework, you might be able to copy the data out of a table that's in a problem, paste it into something like Notepad or some other thing that gets rid of formatting, and then just plop it back in this data set here, this area here. So if I wanted to do this again, I would have to type in all this stuff again like this, right? So again, I don't want to take all the time showing you that, wasting time typing it in, but you see in general how it works. It works the same way. You get your data in here, whether you're typing it in by hand or copying and pasting, and then you click calculate, and you would look here for X bar. Okay. Anybody questions on either calculator? Questions on using either calculator? Again, like everything else, it gets better and easier as you practice it. Okay. All right, so basically what we did here was we summed all of our x of i's and we divided by n and we got 2.54 equals x bar. Again, don't waste your time doing it by hand. Use a calculator. Okay? Now, again, if you look at these data, okay, and you wanted to draw a histogram to represent the data, it might be easier to start with a frequency table, okay? Because if you remember, we used a frequency table to draw histograms before. So I would need to have an X value, which again are going to be my my data points. Typically, you're going to order them. So I'm picking out my unique data points. Okay, and then I'm going to put frequencies next to them. Okay, how many times do they occur in the data? Okay, so we've got one of these, we've got two of these, two of those. Two of those, and everything else has one. Again, you want to make sure if you total up these data here, the frequencies, you get the number in the data set, which was 12. Okay, you just want to double check. So you can see some of these prices occur more frequently than others. So if I wanted to draw a histogram, again, I would have my prices over here. And this would always be my frequency on a histogram. Okay, and it's real easy because I've only got either one or two for the frequency. And so I would want to put my prices along here. Okay, so there are all my prices. And again, if I were to draw the bars on the histogram, this one would be a 1. And then I'd have a bunch of 2s in here. And then I'd have a bunch of 1s towards the end. Okay, so there's my histogram. Okay, everybody should remember that from last time. There's my histogram. Okay. It says, locate the value of the mean and draw a vertical line where it would be located on your histogram. Okay, so here's the sample mean and draw a vertical line where it would be located. Okay, so I'm going to do that. We got 2.54. So it's somewhere like over here. Okay. Now, let me ask you guys the question that comes up next. Does the location of the mean accurately represent where the middle of the data is? Okay, think about that for a minute. Does the sample mean represent where the middle of the data is? I have it drawn in blue on the histogram. What do you think? Okay, let's get some feedback. Okay, and again, feel free to, reply to everybody. What do you think? Does this blue line represent the middle of the detergent prices? Okay, so I'm getting an opinion that says no. I've got two of those. How about the rest of you? Okay, there are 12 of you on. Anybody else have an opinion? What I'm asking is, does where this blue line comes, is where this blue line is on the histogram, the middle of the data? Are most of the prices there? Anybody have other ideas? Okay, I'm concerned by your lack of feedback because I'm wondering if you're confused. Okay. Are you confused about what I mean by middle? Are you confused about what I mean by middle? Okay, if you look at these prices, these are detergent prices. They range from 215 to 435. I did the average thing where I added up all the prices and divided by the number I had. And I got a mean value, an average value of 254. Okay. And basically, if you look at the data, most of the prices are in the 220s. You can even see that by the histogram. Okay. So I would say the mean here doesn't accurately represent the data. No. And it's because most prices are in the 220 to 229 range. Does that make sense? Okay, again, I'm trying to make sense. Where am I getting 1 and 2 from? Oh, you mean on the frequencies, Zainab? Okay, it's how many times each data value occurs. Okay, does that make sense? Okay, anybody else questions? Okay, so you can see from the frequency table as well as from the histogram, most of the prices in my sample are in the 220 to 229 range. They're not up around 254. So this mean is not accurately representing where the middle is. Okay. And again, it's because of a characteristic of the sample mean, and that is the sample mean is influenced by high and low values. Okay. Some of you may have heard the term outlier. I'm not going to use that term because if I use it, I need to define it, and that's not part of what we're going to talk about here. Okay. But you've all had this scenario happen to you. I know I have when I was in school. Okay, all of a sudden you're bopping along, you're getting like an 86 on say your history exam. You do a paper, you get a 91. Maybe you got sick or something happened and you got like a 63 on the next test. What happens to your average? It takes a nosedive. All of a sudden, you've got a C average because of one assignment. Okay, what you're seeing there is the fact that the sample mean is very, very susceptible to being pulled one way or another by a high or a low value. Okay, and if you look at these detergent prices, we have most of our friendly supermarket brands here in the 215 to 233 range. We have a high-end brand at 368, and maybe this is like an ecologically sensitive brand at 435. But in any event, this $4.35, which is almost twice the average, is pulling the mean way up. Okay, it's pulling it out of the middle. So you have to worry about this whenever you're looking at the mean. Okay, how do you get around this? It's like, well, you use a second measure of center. Okay, and again, these statistics, again, remember, are trying to tell you about a whole bunch of data. Okay, so another measure of center is called the median. Okay, and the median, okay, if you thought about it, you might have heard the word median. In English, median is the line that runs down the middle of a road. Right? They call it a median. The median is a line that runs down the middle of a road. It's exactly in the middle. Okay, and that's kind of how we find the median. We find it by having half the data points are below it and half of them are above it. Okay, so in order to be able to find it out, okay, if you were doing it by hand, you would arrange the data in order from smallest to largest and then find a point in the middle. If you have an even number of data points, there'll be the same number on each side. So you average the two in the middle. Okay. So for example, in this case, I have 12 data points. If I arrange them in order, I'll have 6 on one side of the middle and 6 on the other side. And I would need to average the two in the middle to get the median. If you have an odd number of data points, there will be a value in the middle. Okay, with the same number on each side. Okay, does the description of median make sense? Okay, now again, I'm going to show you how to do it by hand, but please don't do it by hand. We're going to use the one variable statistics to get the information. Okay, so I'm just going to show you how to do it. We would first arrange these data in order, whoops, from smallest to largest. And again, it's, if you're doing this, if you're ever stuck doing this, which again, I don't know why you would be, particularly with a spreadsheet that can sort, okay, or a calculator that can sort. Okay, you would probably want to cross them out as you use them to keep yourself from copying things twice. But again, since I did this before, I'll show you, I basically just want to show you the median. Oops. Okay, so I had to go over onto the second line. But you can see, if I count these up, I have 12 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Got all 12 of them. Okay, the median says I want to have 6, half of 12 below the middle and 6 above the middle. Well, since they're in order, the first 6 are guaranteed to be below the middle, and the second 6 guaranteed to be above the middle. So here's the middle, okay, of the data set. And so you would average the two on either side. Well, they're the same, okay? They're $2.28. So I don't need to actually do any math. I can just say the median is 228, because that would be the average of 228 and 228. Okay, let's go back to our TI-84. Okay, I think I'm still sharing that with you. Can everybody see the TI? All right, and here's the result of one variable statistics, okay? This is what came out of it, okay, when we put all these data in that first list and then clicked Stat, and pick the very first entry, one variable statistics. You see here's X bar. And if you scroll down, the little arrow means there's more below. See MED 228. Okay, so you can get the median from one variable statistics. Okay, on the online calculator, I'll go back to that. You would put your data in here and you can see here's median down here. They call it, it's really confusing. It's X bar, but with a short bar. Okay, just use the word median and mean and you'll be able to find them. Okay. So everybody comfortable with calculating median? Okay, using technology. Everybody comfortable calculating the median using technology? Okay, anybody have any questions about calculating the median with technology? Do not do this, okay? If they give you 50 data points, copy paste them and plop them in the online calculator and let the calculator do the median, okay? It's too error prone to do it by hand. Okay, I'm not getting any feedback, so I'm assuming you're okay with the technology. Let's take a minute and look at the histogram we created previously. Okay, here's the histogram we created previously. And if I draw the median on it, you can see the median is right here. Okay, what do you think about the median? Is the median in the middle of the data? Is the median in the middle of the data on this histogram? What do you think? Okay, I've got one yes. Anybody else have any thoughts about it? Is this line I just drew for median in the middle? I think most of you would agree that the median, the black dashed line, is in a much better location to be in the middle of where most of your data is. Okay. Now that brings up an interesting question. Okay, so it does represent it better, and it's in the middle of the data. So an interesting question that comes up is, why would I bother with the mean if the median is a better measure? Okay, the median isn't pulled one way by a high score. You can see that that $4.35 really didn't matter very much in finding the middle of the data. Okay, so why would I bother with the mean? Well, look at the mean and the median together. Okay, that was $2.54. Together. Okay, what do the two of them tell you? Well, you might be willing to say the middle of the data, the most common score is near 228. But what does the higher mean tell you? Okay, the fact that the mean and the median are not in the same place tells you you've got high values in your data. Okay, so basically, if the mean and median aren't next to each other, okay, you're going to basically figure out, oh, well, maybe there are some high values. It's the same thing if I tell you the median score on an exam is an 82, okay, and the mean score is a 76. Okay, the median is an 82, the mean is a 76. What does that tell you? It's like, well, most people scored around 82, but a few people did really badly, and that's what pulled the mean down. Okay, so these two measures together tell you about the way your data is distributed. Okay, so what I want to ask is, everybody understand how to use the mean and median together? Everybody understand how to use them together? Okay. It's one of the reasons why when people are giving you statistics, they almost always use a median value, like they'll talk about median salary in a given city. Okay, they won't use mean because there are going to be people who make a lot less than average, people who make a lot more than average, and it might not wash. Okay, so average is middle. Same thing with housing prices. Okay, even if you look at the zip code that our college is in, the 85042 zip code, you might think, well, the average house price there is probably, around 180 to $200,000. Okay, you'd be right. That'd probably be near the median price. Okay, but there are some houses in that zip code in the foothills of South Mountain that are close to $1 million. Okay, and they would pull your mean way up. Okay, so that's why you need the mean and the median together, okay, to give you that information. Here's another piece of information that is sometimes useful, but we'll throw it in there just so you understand what it's telling you. It's called mode. Okay, mode is the data value that occurs the most often. Okay, it's possible to have multiple modes if multiple values occur with the same frequency. Okay, so you can have one mode if there's one value that occurs more often than the rest. You can have multiple modes if all of the values that recur with the same frequency. As soon as one of them occurs more than the rest, then it becomes the single mode. Okay. Or you can have no mode, okay, if there are no repeating values in your data. Okay, so this might be useful to you. I only thought of one example where this might be useful is if you were, say, running a mom and pop restaurant and you had an old style cash register that actually had the paper tape in it, and you were offering, say, a breakfast or a lunch special, and that was a certain price, say $5.99. Okay, and you noticed when you looked at the tape later how many $5.99s were there, so you could see, oh, am I selling a lot of the breakfast special, or should I change it or get rid of it? Okay, is it the mode? Okay, so again, here are your detergent prices again. And I think we could see from our histogram, okay, we have a bunch of prices that occur twice: 220, 222, 228, and 229. So all of those would be the mode. Okay, so you have 1, 2, 3, 4 modes in this data. If we got a 13th piece of data and it was the detergent price 229, then 229 would become the only mode because it would occur 3 times and everything else would be twice. Okay, so again, I'm going to put that down here. And that's because they all occur twice. Okay, if you're trying to find modes on a TI, okay, here's my TI again. And let's turn it on. I'm going to clear this. I think that one variable statistics will print you a mode. So let's do stat again, calc. All right, so I'm going to scroll through all these data and see. Okay, no, it does not tell me what the mode is. So if you wanted to see mode, okay, what you'd need to do on a TI is you'd need to sort your data, and that would put repeats together. Okay, so let me show you how to do that. So I think it's in list ops. Yeah, sort ascending. So sort A, and then put list 1 in here, right? And it will basically show you, if I go back into list 1, it's now got my data sorted. It's not going to affect any of the statistics, okay? But now the data is in order, okay? And I can see, oh, there's 220 together. There's two 222s. Here's two 228s, 229s. And then everything else is a single, okay? That's the best you can do, I think, on a TI. I'm not sure if there's a single mode function. Let me check in the list math. No, I'm not seeing a mode. Okay, so your only deal on the TI is sort your list. Okay, that's in list ops. So second list ops, sort ascending, sort descending. It really doesn't matter which one you pick. It just will put repeated values together. Okay, most of the other like online calculators, like this one that I'm showing you, okay, they will actually pull out the mode here. Okay, and they should put multiple modes here if there are multiple modes. Okay, I'm beginning to think it might be helpful if I just put these data in so you can see how this works. And this is 220, 222. Again, just trying to show you the details rather than explaining it, because I know a lot of folks would rather see it than hear me talk about it. So let me just get all these data in here. Okay, so hopefully that's all 12 of them. Calculate. Okay, so it gives me a minimum, a maximum. It tells me how many I have. It tells me the mean, which I figured out, the median, and look at all the modes that are listed. Okay, so you can see here. Okay. Okay, so see the mode in the online calculator. I'm going to list multiple modes. If it's blank, you know there's no mode. Okay. So I really, really like this calculator, and it has the advantage if you've got data in a table or in an Excel spreadsheet or whatever, you can copy paste the data. You can either do comma delimited like this, okay, or you can do it the way I did it, where you've got every data entry on one line, okay? So online calculator is easy. Okay, it's easy to use. Okay, anybody got questions about mean, median, and mode so far? Anybody have questions on those? Okay. All right. So not seeing questions. So here's one you can try. All right. So again, I'll work this with you after the fact, but pretty much this is it. I mean, you know, it isn't any more complicated than this. So I'm going to ask you try this example. Okay. And basically try parts A, B, and C. Okay. Part D is asking you about putting them on. Don't worry about those parts. Just do the ones you can see. Okay. You try this example, parts A through C. Type done when you finish. Okay, so actually try this one. Okay, and you can use your TI or you can open up that online descriptive statistics calculator in another tab. You might want to start out by building a frequency distribution. Take another minute or so. I have the histogram up if you want to take a look. But just see if you can do the sample mean and the median using technology. Okay, folks, well, let's all come together. I know some of you are probably still working on this, but let's come together to make sure we're all on the same page. What I did before we got started was I built a frequency table of the data they gave me. Okay, the first thing I had to do is figure out what's the lowest value in the data, what's the highest value in the data. And then I listed the data points from 3 through 8, because that's what's in the data, this number of hours that people sleep on average. Okay, and then I counted how many times each data value occurs. Okay, 3 occurs once, 4 occurs twice, 5 occurs twice, and so forth. Okay, so I put how many times each value occurs in the frequency column. That's going to help me build a histogram by hand, right? Because I can see where my frequencies need to be on the left. Okay, the highest one is 2. And then I just make bars that represent the frequency for each data value. Remember, if you can build this in Excel, the analysis tool pack in particular, will build you a really nice histogram. Okay, there's a histogram in the charts section of regular Excel, okay, but I think it's a lot easier to manipulate it and build it the way you want if you add in the analysis tool pack. Okay, again, not an Excel course. Okay, but if you do have questions on it, feel free to ask me offline and I'd be happy to work with you. If you're going to need to be building histograms like this. Okay, nobody does them by hand. Okay. Now the sample mean, okay, we can do one of 2 ways. There's not a lot of data here, so I just want to show you on the TI how you use a frequency list on the TI. Okay, so here's my data. Let me turn it on. Okay, I'm going to go into stat and I want to delete the first list that I put in there before. So I'm going to go to clear list and then list 1, get rid of what's in there, then stat edit. Okay, and I'm going to put the values, right? 3, 4, 5, 6, 7, 8. I'm going to put that in list 1, and then the frequencies in list 2. So 1, 2, 4, 6, 1. Okay, the trick when you're using a frequency list on the TI, make sure you've got the same number of entries in both lists. Okay, that's kind of a necessary thing. Okay, so I have my X's in list 1, my frequencies in list 2. I'm going to quit out of here. And then I'm going to go into stat, calc, 1 variable statistics again. Okay, I have my data list, my data values in list 1. And now I'm going to arrow down to my frequency list. And I'm going to add list 2 there. So second 2. Okay, so if you're going to use a frequency list, remember to put it in here and then calculate. Okay, and it gives me X bar, which to 2 decimal places is 5.33. Okay, and if I scroll down, I can find mean. Mean is 5. Okay, everybody all right with those 2? Again, the advantage of the TI is it lets you use a frequency list. That can be really handy if you're typing in data from a frequency distribution. You might notice on this calculator, there's no facility for a frequency list. You might want to look around and see if there is another descriptive calculator that lets you put in a frequency list. Okay, but with this one, I would need to actually, let me clear, I would actually need to put in the values the way they're written. So 5, 4, 7, 6, 6, 3, 5, 8, and 4. So I'm not using frequencies. And then I'd say calculate. And again, you'd see I would get the same thing. There's my X bar, there's my median. Okay, this will even tell me my mode. Okay, so difference here is with the online calculator, this particular one doesn't accommodate a frequency list. All right, so you decide Okay, what works for you. Okay, now they're asking me, locate both the mean and the median on the histogram. Okay, well, the median is kind of a little bit past here. So here's the mean. And the median we'll put right next to it. They're pretty close. Okay, so these are fairly close. Okay, you can kind of say that the median is better, but really you can use either one. Median is better, or it's closer to the middle. Okay, the mean is a little higher because of the 8. Okay, there are more values that are high, right? 7 and 8. Okay, and again, mode, we got that calculation from the calculator. I'm not going to calculate it again. It's essentially all of the values that repeat twice. So the modes are 4, 5, and 6. Okay. Anybody have questions about this example? Anybody have questions? Okay. Again, the most important thing to take away from here is you need both the median and the mean in order to tell not only where the middle of your data is, that's almost always going to be better indicated by your median, but your mean can tell you whether the data has high or low values that are pulling the mean one way or the other. So questions for the last time, anybody? Okay, not hearing any. Okay, so questions about anything? Anybody have questions on anything?